हाय बच्चों, कैसे हैं आप लोग? उम्मीद है कि सब लोग ठीक ठाक हैं। I hope you are studying your lessons properly in this lockdown period. Kindly utilize this period for your maximum benefit. There are a lot of limitations out there in online teaching. Okay, many of you may not be having high-speed internet connectivity in homes. I know many of you are still stranded in your villages. I hope and pray that may God guide you in your journey once you come back to Dimapur. So without wasting any time further, I would like to start for today's discussion. So kindly make sure you watch this video right from the beginning to the end. So let's get started, all of you. In the last class, I have already given you the notes about the different types of voids. Okay, voids means empty space. In English language, voids means empty space or gaps. Okay, so we know inside the solids, no matter how much you arrange the atoms in a tight, precise manner, still there are bound to be some empty spaces. Okay, similar is the case when you pack your things for going somewhere, right? When you pack your things while going somewhere, you pack it tight, but still there may be some space where you can keep some other small items inside. In the same way, inside the crystals also, there are some empty spaces, and those empty spaces that are formed as a result of the close packing of the atoms. Such empty spaces are called voids. Okay, so voids are also known as interstitial sites. Okay, we'll be coming to that. I hope you have already seen that explanation and you have gone through the notes. So today we are going to derive the relationship between radius small r of an octahedral void and the radius capital R of the atom. Now, in an octahedral void, what is happening has been explained with the help of this figure. So in this figure you see that there are three black spheres, okay, drawn by black marker. So three black spheres are there. They are arranged in such a manner, and on top of that you have another three red spheres that are closely packed, and they are arranged in the form such that if you join the centers of these atoms, they form an equilateral triangle. Okay, so you have two equilateral triangles as a result of these six spheres, and they are heading in opposite directions. So such kind of void, you see some empty space in the middle out of that arrangement. Okay, so first I draw three red marker pen. Using red marker pen, I draw three spheres, and using another three spheres, using the black marker, I have drawn another three spheres, and I have joined the centers of that spheres using straight line, and they form two equilateral triangle. And you can see a gap in this middle point here. So that gap is called octahedral void. Okay. So drawing this kind of arrangement, for setting it in a simple manner, it's quite difficult. So for that reason, we are going to do a derivation here. Relationship between octahedral void and the radius of an atom, right? So here you may be seeing in this figure closely that Sir has drawn only four spheres, but actually in octahedral void, Sir has explained a few moments back there are six spheres. But actually here there are six spheres, but I am not able to draw it on the board. Two spheres, one sphere on top of this void, and another sphere will be on the bottom of this void. So it's not possible on a two-dimensional plane board. Okay. So let us consider four spheres here, and the radius of these four spheres are capital R, and the radius of this void, okay, the gap in the middle of the four spheres, actually there are six, okay, don't be mistaken here, there are six spheres. The gap in the middle is denoted by this red sphere, okay, or red circle, and that gap we are placing a constituent particle or an atom, and that radius of the void is considered to be here small r for mathematics point of view. So I have marked the points as A, B, C, D, okay, and I have considered the radius of the void as small r, and I have considered the radius of the atom as capital R. Okay, so let me start the derivation straight away. So let us discuss how much smaller is the void compared to the radius of the atom, or how much larger is the atom when compared to the radius of the void. So let us derive a mathematical relationship for this. Okay, let's get started, all of you. So kindly take your notebook and note it down as I do this derivation. So let me get started. Let AB is equal to BC is equal to CD is equal to DA is equal to R. Okay, we can consider this as A, all of you. A is called edge length. I believe you know it. Okay, this A is called the edge length of the unit cell. So ABCD is a unit cell. Okay, consider ABCD as a unit cell. So let AB equal to BC equal to CD equal to GA is equal to side is equal to sides, okay, of unit cell. Sides of the unit cell. Okay, consider this as a cube. You know cube has got 6 faces, so 6 faces can be considered as the 6 sides. Okay, and then let capital R be the radius of the sphere. Okay, let capital R be the radius of the sphere. I think I have understood so far. And small r be the radius. Small r be the radius of the void. Okay, what kind of void it is, Bacho? It's octahedral void. Okay, I hope you have understood up to here. Now I'll use a bit of mathematics here. Okay, in physics and chemistry, we always make use of mathematics to derive some relationship between something and something, right? So let us do that. In right triangle, okay, in right triangle ABC, I'm going to use Pythagoras theorem here. Okay, in right triangle ABC, let us assume that AC is the hypotenuse, right? We can say AC is equal to root under AB square plus BC square. This is coming from Pythagoras theorem. You might have already studied in class 10. Okay. So what is AB, बच्चों? AB आपका A है. AB is your A, edge length. What is BC? BC is also your edge length A. Okay. Now it's coming square root of 2A square, and square root of 2A square is nothing but it is square root of 2A. Now बच्चों, AC is square root of 2A. Now what is this A? Okay, A is called edge length of the cube. Now A is not much of significance because you are going to find out the relationship between small r and capital R. Okay, so A is not much of significance after this point. Okay, so but we know that A signifies 2r. A signifies 2r because edge length is nothing but r plus r here. Okay, the radius of these two spheres, ये वाला स्फीयर और ये वाला स्फीयर को कंबाइन करने से हमको 2x r मिलता है. ठीक है, तो बट AC क्या होता है? AC, you know, from this point to this point, this is the radius of the sphere. From this point to this point, this total length will be twice r, smaller, and from this point to this point, another r because it is the radius of the sphere. So we can write this AC as r plus r. What is r plus r? 2 capital R plus the diameter of this sphere. You know, radius is smaller, diameter will be twice smaller, root 2, right? And you know, A is what, बच्चों? A आपका होता है 2r. A क्या होता है 2r. Why? Since A equal to 2r. Okay, you can see from geometry there. Now I'll take something common here. I'll take 2 common. I'm getting r plus छोटा r. Now root 2 2r. 2 goes. What comes? R plus r is equal to root 2r. I hope you are clear. Please copy down up to here. Now I'll try to eliminate this capital R. Okay, over the right hand side. How will I do it? I'll divide by r on both sides. I'll divide by capital R on both sides. So when I divide by capital R on both sides, I'll get r by r plus r by r is equal to root 2 r by r. Now this r and r goes, this r and r goes. So what comes? I'll rough this portion. Okay. What comes, all of you? 1 plus r by r is equal to root 2 will come. Right. Now we can write r by r is equal to root 2 minus 1. 1 I am taking this side. Okay, to the right hand side. Or I can say that subtracting minus 1 on both sides, right? That is the correct way of saying it. So r by r is equal to, what is the value of root 2? Use a calculator, or else if you know it, 1.414, okay, minus 1. So it comes out r by r is equal to 0.414. Alright, now what is this r? This is the radius of the void, small r. And what is this capital R? Capital R is the radius of the atom or the sphere, right? And the relationship between the radius of the atom and the radius of the void is nothing but r void divided by r sphere is equal to 0.414. Okay? Now this is a very important relation. Kindly keep that in mind. And for the tetrahedral void, I want you to do by yourself. I'm just writing the relationship on the board for the tetrahedral void here. For the tetrahedral void, okay, all of you write down. Such kind of numericals can be asked. For, or just write down the topic, relationship between radius of atom and radius of the atom and tetrahedral void. Tetrahedral void radius. Okay, that is small r here. This is capital R. You have to remember the formula, that is r void divided by r sphere or r atom is equal to 0.225. Kindly note it down in your note copy, and I want you to do this derivation in your note copy. You will be there in the textbook. Similar type of derivation. The concept is little bit different, but mathematics are more or less the same. Okay. So I hope you have understood this derivation. Alright. Now, kindly copy down in your note.